Good afternoon, students. So, today we are going to start our first chapter of 11th mathematics, namely set theory. So, before starting the chapter, we first recall some of the school mathematics concepts. Okay, then we have to go to the chapter. So, let's begin. So, till class 10, we have already studied various type of numbers, right? So, what are the types of numbers you study in till class 10? First is natural numbers. So, what symbol you are using in school for natural numbers? It is capital N. And what is the natural numbers? Now it is the basic counting numbers, right? And how you noted these numbers? By using curly bracket. The elements are 1, 2, 3 and so on. Correct. Then whole numbers. And the notation is capital W. What is whole numbers? Natural number along with 0. So 0, 1, 2, 3 and so on. Then integers. What is the symbol we are using? Z. What is integers? These are 0 along with positive number and negative numbers. That is dot 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 minus 2, minus 1, 0, 1, 2 and so on. Then we study rational number, irrational numbers and real numbers. And real number contain all of these, right? So tell me one thing, while I am saying natural number, then am I talking about a single number or collection of numbers? You understood my question, right? So when I say natural number, am I talking about a single number or a collection of numbers? Very good. So it is not a single number, right? It is a collection of numbers, since it is not contain a single number, right? Similarly, when I am talking about integers, that means I am talking about a collection of numbers. So whenever I am talking about whole number, I am talking about collection of numbers. So these are not a single numbers. So these are collection of numbers, correct? So what is said? It is the mathematization of the word collection. So set is nothing but it is mathematization of the word collection. Now the question is, what type of collection is, how to mathematize the word collection? Is any random collection is a set? No. So to answer this, we have to go through the set theory definition. Set theory. So what is the definition? A well-defined collection of distinct objects is called a set. So this is our definition, a well defined collection of distinct objects. So whenever any definition I am saying, so what you need to do is, instead of memorizing the definition immediately, try to understand the definition. You are giving JEE Main exam, right? So in that exam it is not going to ask you directly write the definition. The what you need is, you need to understood the definitions. So to understood the definition, the better way is break each and every part of the definition and try to understood each part. So what is collection means, you understood. Now we have to collect distinct means difference. Then what is meaning by object? Here object means it is same as science, okay, any living or non-living organism. That means either you can check alphabets or letters or numbers, etc. This is my objects means in mathematics. Now look at the term well defined. This thing you need to understood very well. So what is the meaning by well defined? The word well defined means there is no ambiguity regarding inclusion or exclusion of objects. Inclusion or exclusion of objects. What it mean? That means there is no confusion or ambiguity regarding inclusion and exclusion. Means you have to include that object in the set or not include that object in the set. That means it should be independent of person. What it exactly mean? So for example, if I am saying, suppose A is a set having elements are natural number. What are the natural numbers? 1, 2, 3, 4 and so on. So if I ask to Lavanya, then for Lavanya also the set A is same element, right? For Bharti also the set A is same elements, right? And if I say each 6 is a element, 6 is a part of the set A or not, you include 6 or not include. Here 6 is the part, 6 is include. So there is a no confusion regarding 6 is a part or not. That means there is no ambiguity. The rule is clearly justified or mathematized. So you can include or not include. The definition should be well defined such that you know the element is part or not. This is your main aim. So this set is a well defined. So this is set. Now For example, someone telling, let me find the collection of good cricketer. So B is equal to collection of good cricketer. Now, suppose for Lavanya, Virat is a good cricketer, but for this is for Lavanya, Virat is a good cricketer, and for Bharti, suppose Dhoni is a good cricketer, but both are different, right? That means it is depend on the person. So collection of good cricketer is not well defined. If anything we are in mathematics, if anything we are saying, it should be unique, and if it is not unique, that means it is not well defined. So that means collection of good cricketer is not a set. It is a collection, but it is not a set. Why? Since it is depend on the person. So if I bring some other player, suppose I am being Sanju Sansam, it may possible for Ravi he is not a good player, or for good cricketer someone may be choose a batsman, someone may be choose a bowler, someone may be choose a all rounder. So if I am telling any quality base or character base, that should be not a well defined. You understood, right? So let me give another example. For example, suppose I want to collect collection of beautiful flowers. Now tell me, is it a set or not? So you observe, right? For some of students, rose is the beautiful flowers, but for some of students, lotus is the beautiful flower. Maybe for some of students, lily is the beautiful flower. That means this depend on the person. So there is an ambiguity in inclusion and exclusion. That means this collection is not a set. Why not a set? Since beautiful is not well defined. It may possible for someone beautiful means smell. May possible someone beautiful means it's circular or any other shape. So beautiful is subjective, right? So it is depend on the person. So due to that reason, this is not well defined. So if it is not well defined, that means it is not a set. So I hope you understood what is the meaning of set. So what is the meaning of set? A set must always be a well defined collection. So what is said? It is a collection. What type of collection? It should be a well defined collection. Well defined collection of what? Objects. Objects can be anything. What type of objects? Distinct objects. So sets is a well defined collection of distinct objects. So I hope you understood the definition of set. If you have any doubt, feel free to ask. Pause for a moment, think, then proceed. Now, So in generally sets are denoted by capital letters. For example, capital X, Y, Z, A, B, C, etc. And objects in the collection are called elements and denoted by small letters. For example, small a, small b, small c, small x, small y, small z, etc. So it is in generally, okay, it is not like the thumb rule we have to note it, but in generally we are adopting this. So usually we are writing by this notation. So like you see in the school also, right? Natural number capital N, whole number capital W, integer capital Z, rational number capital Q, real number capital R. So usually this notation we are using for capital letters for denote the sets and small letter to denote its elements. So whatever inside the collection, it is called elements. For example, suppose I have a set A having in that collection it contain 1, 2, 3, 4, 5. Then what should I say? 1, 2, 3, 4, 5 are elements of set A, since it is the part of its collection. And suppose I am collecting X is equal to the collection of natural numbers greater than 10. Then what are the numbers? 11, 12, 13 and so on. So these all are called elements of the corresponding sets. Now we have a note here. So if these are the elements, okay, then the question came how to donate it in mathematically. Correct. Whatever you may ask one question, whatever sir you told it is okay. 11th is the element, 12th is the element, 13 is element, all are the elements. Is there exist any notation by using what we can represent in mathematically? So that notation we will see here. So if small a is an object collected in the set A, then we denoted it by the symbol A belongs to capital A. So how to read this? A belongs to capital A. That means, or we can read like this: A is an element of capital A. Here capital A is our set, A is its element, capital A is the set, A is the element. Then we have to notate this. So any collection are there in the set are the element of the set. How to notate this? By using this symbol. What this symbol is called? Belongs to symbol, or we can say is an element of. Okay. So this is how we can represent the elements of a set. Now there are two types of representation of the set. So how to describe a set? We have to describe a set by using two types. What are the types? First one is roster form. So what this form is telling? Elements are listed using command brackets. For example, suppose my set A is 1, 2, 3, 4. This is called in roster form. That means it contains all the elements or all the collection in the form of commas. Another example is, suppose set B is equal to collection of all the vowels. This we can write as roster form. How? What are the vowels? A, E, I, O, U. So writing all the elements in the form of commas with curly bracket is called roster form. Now another form is there. It is called set builder form. We will call either set or we can call collection. Builder form. Builder form or builder notation, anything you can say. So this is a way to denote the sets. So what the rule is, suppose the set I am denoting capital X. So how to collect the elements, how to represent elements of the set in this form is X should be types of object and rule for the collection. So, for example, this is my format in order to represent any sets in set builder form. So, in order to any object to be elements of this sets or this form, it should be satisfy both this, it should be types of that objects and satisfy the rule of the collection. This is needed for well defined, right? For example, suppose my set X is equal to small x is a natural number such that x is less than is equal to 5. So this notation you have to read as such that. This notation read as such that the type of object should satisfy the rule for collection. So what is this set? You already know, natural number and less than equal to 5. That means natural number start from 1. So let me explain this way. Our collection should be satisfy both condition, right? This condition, it should be natural number and should be less than 5. For example, if I am taking numbers root 2, is square root of 2 is a natural number? No. Is square root of 2 is less than 5? Yes. But it not satisfying both condition, right? Since it not satisfy both condition, so is square root of 2 is the element of set X? No. That means square root of 2 is not belongs to capital X. Similarly, if I take 6, each 6 is a natural number? Yes. Each 6 is less than equal to 5? No. That means it not satisfy all the condition. That means 6 also not a element of X. Then let me take 1. Is 1 satisfy as a natural number? Yes. Is 1 is less than equal to 5? Yes. That means 1 is the element of X. So if both satisfy, then it become the part of the set. So what is the set X then? It should be from 1, 2, 3, 4, 5 only. That means root 2, 6, pi are the not part of the sets, not the element of the set X. In order to any of collection become its set, it should be satisfy both condition. What are the both condition? It should be satisfy the type of the object and rule for collection. If it is satisfy both, then you can make them a part of this. Otherwise you are not. Okay. Now let us solve some question. Question 1. Write the set 1, 2, 4, 8, 16, 32 64 in set builder form. Clearly it is already in which form? Roster form, right? Why? Since bracket or curly bracket, elements are written in comma, so it is collection of the elements is written, right? So we have to convert in set builder form. How to solve? In order to convert it into set builder form, we have to find what type of object it is and what is the rule for the collection. The rule should be satisfied by the all the elements. It should not like that for each and every elements we have different rule. That rule will satisfy all the elements, and you can clearly see through this example, set builder form cannot be unique. Okay, roster form always unique. It does not matter in how you are arranging the elements. The order of the elements is not matter. Correct. If I am asking, give me natural number which are less than equal to 5, either 1 2 3 4 5 you are writing, or 4 5 3 2 1 you are writing, the numbers are same, right? So order is not matter. But in roster form it should be always unique, right? But in set builder form it may not be unique. How? We'll see here. So clearly this set, let x is equal to, this is my x is equal to given 1 2 4 8 16 32 64, correct? So clearly we can write 1 as 2 to the power 0, 2 as 2 to the power 1, 4 as 2 to the power 2, 8 as 2 to the power 3, 16 as 2 to the power 4, 32 similarly 2 to the power 5, and 64 become 2 to the power 6. And these numbers also, all the numbers are positive divisor of 64, right? So how to write in set builder form? So this is nothing but x such that, so types of object is x such that x is equal to 2 to the power n and x belongs to whole number with x is less than or equal to 6. Or another way you can write x such that x is equal to 2 to the power 9, where, so this would be my n is equal to 0 1 2 3 4 5 6. Another way is x such that x is positive divisor, x is positive divisors of 64. Clearly these are all are positive divisor of 64, right? So that means set builder form cannot be unique, but set roster form always unique. Let me solve another question. So the question is, write the following set in roster form. So the set is given, capital C is equal to x such that x square plus 7x minus 8 is equal to 0. So clearly, in which form it is giving? Set builder form. Type of object x, rule for the collection is this. So we have to convert in roster form. So how to convert? In our expression we have to solve this. X square plus 7x minus 8 is equal to 0. You know in school, right, how to solve the quadratic equation. Two way are there. Either split the middle term or use the formula. What formula? If the quadratic equation is ax square plus bx plus c is equal to 0, then x is nothing but minus b plus minus under root of d divided by 2a. What is d? It is nothing but b square minus 4ac. Either you can do that or split the middle term. How to split the middle term? You have to find two numbers whose product become minus 8 and sum become 7. So if you do that, you will get the roots are 8 and minus 1. So this thing I can write x plus 8 and x minus 1. This is equal to 0. This implies x is equal to 1 comma minus 8. So both are real number, right? So what is my set C? It is nothing but minus 8 comma 1. I hope you understood what is set and how to denote any element which is part of the set or not, the belongs to notation, and how to represent the sets, with how to convert any set from set builder form to roster form and roster form to set builder form. So